So on Tuesday, we didn't get a chance to do this extra exercise because we had so many questions about grades and the exam. I don't know if we'll be able to get to it on Thursday, but here is one more example of that sampling distribution for a sample proportion. Now, again, on the test, I'm going to be nicer to you than this question because I will have a part A which says, what is the distribution? Which basically tells you, oh, right, go find your mean and standard deviation. And then part B will ask you to find a probability. So this one, the training wheels are not on. So this one's a little harder than what you'll see on a test. So reading through exercise 2, we have according to this surveillance by the CDC, 39% of 10th graders said they watched 3 or more hours of television on a typical school day. So we just got a P. Now technically, this was probably a P hat, right? But look at the next sentence. It says, assume that this percentage is true for the population. So while this is probably a P hat from some sort of sample or survey that the CDC did, we're going to assume it's true for the population. So we can erase the hat and call that P. And then it asks us to find the probability, which generally means area under the curve, because most everything we tackle in this class ends up being normal, but we don't know that necessarily. That 43% or more out of 200 students watched 3 or more hours of television. So we got an N, and then we got a percentage given to us in the same sentence as that N. So that is going to be a P hat, the sample proportion, the value or the percent or proportion from that 200. So we got that 0.43 there. We also have one more additional thing. We were given a direction, right? So if we really wanted to translate stuff here, we're looking for a probability of getting a P hat equal to or greater than 0.43. Personally, I don't love the probability notation. I find it confuses a lot of students, but that is what we're looking for. Instead, I look at this and I go, okay, we're looking for something about a sample proportion. We know stuff about a sample proportion, right? We know sample proportions are approximately normal with a mean and standard deviation on the formula sheet. So here's the formula sheet that you had on the last test and you'll have on the next test. And we have here, remember, we'll have this sort of as a keyword on part A on our exam, but it says we want to do something with a sample proportion, and we know that the mean and the standard deviation are given here on our formula sheet. So I'm going to take this information, I'm going to go ahead and go back to our, my God, I have too many things open, our lecture notes and input that. So that information was that the mean for our P hat is 0.39, the value that we said it was assume is true for the population. And if that's true, then when that has a standard deviation of 0.39, because remember, I should have written down the formulas with the P's in them, and then we'll plug in. This is P. This is PQ divided by N. So remember, this P hat here is just one observation. So we're basically asking, well, 43 is not 39, so what's the probability of getting that or something bigger than that, right? So 0.39. Q is just 1 minus P, so 0.61 all over N of 200. So this is step 1. This is just like our normal approximation to the binomial. Go find the mean and standard deviation that is not what I want, that we're going to use. So square root 0.39 times 0.61 divided by 200. Notice that I don't use any parentheses here. The most common mistake students have when using anything here, especially with the older calculator without the math type, is that they close the parentheses too early. So this is the first parenthesis right here. You want to make sure your second parenthesis is after. So 0.0345. And you do want to keep 4 decimals because otherwise we're going to end up dividing by this when we find our z, or when your calculator is finding a z-score, and it can end up different if you round too many spaces. So once we have this information, technically we should check that we have normality. In order to check normality, that would be seeing that we have a simple random sample. Nothing actually said how we got the 200, so this is a question mark. We'd want to show that those people were independent, which should be guaranteed if we have an SRS. Again, we don't know that, so that's kind of an iffy. We want N to be less than 10% of the population. So is 200 less than 10% of all 10th graders. Yeah, we're good there. And we need our NP and our NQ to be greater than or equal to 10. So in this case, 200 times 0.39 and 200 times 0.71, we want to verify that those are both greater than or equal to 10. If all that is true, then we have an approximate normal, and we can move on to step 2. If we have normality, we can draw a beautiful curve centered at that mean of 0.39. We were interested in 43% or more, so 0.43 or more. The most common mistake I have students do on this problem is they want to do inverse norm because they see a percentage, they know it's a normal question, and previously that was an inverse norm. But we know our cutoff. We want a probability. So this supersedes everything and tells me that we are going to be using normal CDF with a lower bound of 0.43, an upper bound of E99, the mean and standard deviation from part 1. So that's it. That is using a sampling distribution for a sample proportion. So I'll go ahead and just finish this off. I'll pause it so you don't have to watch me type in slowly. So it looks like we end up with 0.1231. That's our probability, or 12.31%.